Let's walk through an example of curve sketching. So we're going to calculate all of our min-max, we're going to calculate our inflection, and we're going to find the intervals over which the graph is increasing or decreasing, and concave up or concave down. Step one, we want to find our first derivative. It will tell us about slopes. It's 3x squared minus 6x minus 9. And to find our critical numbers, we'll set that equal to 0 and solve. So x squared minus 2x minus 3 equals 0, just to make it a little simpler. And this factors x minus 3, x plus 1, giving us x values of 3 and negative 1. So these are places where the slope will be equal to 0. What I'm going to do to organize my work, I'm going to create a number line with negative 1 and 3. And I'm going to test the first derivative over each of these three intervals and see if the graph is increasing or decreasing in those sections. So for this first interval, I'll plug in something less than negative 1, say negative 2. And we're going to get something, we have to plug it back into the first derivative here. 12 plus 12 minus 9. All we care about is if it's positive or negative. We've learned that the graph is increasing over that interval. For the middle interval, I'll plug in 0, which gives us negative 9, so that's a decreasing negative slope. And for the right of 3, I'll plug in something like 10, giving us 300 minus 60 minus 9. Well, that's going to be positive as well. Now, it's important that we now recognize we have identified mins and maxes. Since the graph goes from increasing to 0 to decreasing, we now know that negative 1 is our max, and vice versa, going to 0 and increasing, we now know that 3 is our minimum value. Let's move on to concavity, and for that we'll use the second derivative. So the second derivative of x, and be careful, make sure you go all the way back to the first derivative, equals 6x minus 6. And let's figure out our potential inflection point by setting it equal to 0. It gives us the value of x equals 1. We'll do a second number line for the second derivative, and I'm going to try and line it up with the first one just to make it a little bit easier to work with later when we get to the graphing step. And so again, I'm interested in analyzing the intervals over which it's concave up and down. For this first interval here, I'll plug in something like 0. 0 minus 6, that's negative, so I know it's concave down. And for this right side, I'll plug in something like 2, which is 12 minus 6, which is positive. So the fact that the concavity switches now means that I know that this is an inflection point. All right, we should be ready to create a graph at this point. And we're going to need to be able to kind of read these different values and understand how they affect the graph in order to create a sketch that is accurate. To start out, I'm going to want to be able to graph my min-max points and my inflection, so we should just go ahead and calculate what they are. My minimum value, well, remember when x was 3, you're going to want to plug 3 back into the original function to find its y-coordinate. And you can check my work if you want, but when you do, you'll get a negative 28. Doing the same with the max. The maximum value, remember, was when x was negative 1. And that will happen when y is equal to 4. Again, plugging it into the original function. And same with the inflection point. That is when x is equal to 1. And we get a y value of negative 12. And so I'm going to go ahead and graph those points. Keeping a scale that seems kind of reasonable here, so we can count on the y-axis by 4s, meaning we get to negative 12 approximately here, and 16, 20, 24, 28 down here when x is equal to 3. And just give enough information to make sure someone kind of knows the scale that you're using. And then we're going to start looking at the shape of our graph over different sections. All right, so the first section is everything left of negative 1. When we are left of negative 1, we will see that we have a slope that is positive and a concavity that is negative. And so that's going to apply to the entire section to the left of -1. And so we can graph a positive slope with negative concavity. And getting precisely how steep this is or where it crosses the x-axis is not that important for our purposes here. If you wanted to be super accurate, you could calculate the x-intercepts as well, but we're not going to do that for this exercise. For our next section, it's everything from -1 to +1 between the maximum and our inflection point. And over this interval, we found that the slope was negative and the concavity remained negative. And so that's going to kind of curve down until we hit that inflection point there. Over this third section, from 1 to 3, we found that we still have a negative slope, but the concavity switched to positive. And so we start curving up until we hit our minimum value. And then for the rest of the graph, we find a positive slope and positive concavity. So it turns back up. And there's our graph of the function using first and second derivative to help us calculate the shape of the graph as well as min, max, and inflections.